And I'm from National Museum of Japanese History, Japan, and I'll make a presentation about documentation of knowledge accumulating and clustering in the context of khirin, which is digital platform of our institute. Designing, building, and maintaining khirin is a collaborative project with my colleagues. Yeah, yeah. This is the agenda of my presentation. Main topic of this presentation is model of knowledge accumulation using CIDOC CRM and schema.org. To illustrate that, we introduce the background, that is, our presentation in CIDOC 2020, and propose a model to illustrate archival hierarchies and update activities. Additionally, the detailed description of those activities is also connected to them. Finally, I'll explain that not only archival hierarchies, but also other types of groups are represented in the similar way. In the CIDOC 2020, we made a presentation titled Documentation of Ethnographical Object Biography using CIDOC CRM. In that presentation, we modeled information about ethnographical objects using CIDOC CRM. The dataset we used for the modeling were derived from handwritten records, rekiminkas, which documented data collected through historical and folklore surveys conducted by the Agency for Cultural Affairs in Japan in the early 1970s, and documents about related projects. The example here is one of those survey records describing a kind of Japanese clocks. Name, location, and so on are documented in the process of completing the form, and photograph and a diagrammatic sketch are attached. The CIDOC CRM is an ontology in the sense used in computer science, so that can be represented as connected graphs like this. This is a part of the graph. We developed linked data platform named khirin and stored those data in RDF. Therefore, extension of CIDOC CRM is performed in that layer. In other words, we used and developed some properties other than CIDOC CRM. There are some problems we faced in the modeling process. We discussed 8 of them in the presentation in CIDOC 2020. Today, we focus on 2 problems, which are mutually related. That is, how to represent knowledge accumulation and how to represent groups of knowledge. From fieldwork to digitization and analysis, knowledge is accumulated for each human-made object. How can we distinguish the knowledge acquired from different activities with representing them in CIDOC CRM? That was the problem. In the domain of archival science, hierarchy of the groups of documents is very important to understand the archive as a total and each document. khirin, our digital platform, used vocabularies in schema.org to represent that hierarchy before introducing CIDOC CRM vocabulary. Not only the hierarchy, but also the activity related to them are modeled. We wanted to connect this word with documentation of ethnographical object in CIDOC CRM. So, by the way, why do we have to connect and use both vocabularies? Why is only using CIDOC CRM not enough? Detailed reason is added in the latter part of the presentation, but there is a background in the metadata sharing environment in Japan. There is a platform named Japan Search, that is jpsearch.go.jp, developed under the project of Japanese government, National Diet Library, and so on. That is sometimes called Japanese Europeana in Japan. So that is expected to be the hub of cultural metadata, analogical with the situation that compatibility with Europeana data model is required in the European museums. We have to have compatibility with schema.org. That is one of the reasons. While Europeana data model contains the vocabularies of CIDOC CRM explicitly, schema.org doesn't, and we have to map those vocabularies. Moreover, there are some other projects, including Wikidata, mentions vocabularies in schema.org as same as property of its own property. Wikidata is a knowledge graph and a common source of Wikimedia projects, such as Wikipedia. We use some entities in Wikidata, especially cultural institutes and people. So compatibility with Wikidata is also important for us, and thus compatibility with schema.org is beneficial in the wide context. To return from the digression, we have to find the CIDOC CRM equivalent of schema is part of, that is a property in the schema.org. By searching archive in the CIDOC CRM document, that is 7.1.1 version, I found P198 is held or supported by, and that example of that seems to illustrate the hierarchy of archives. For example, archival folder 17 holds or supports the daguerreotype that shows the image of Henry Ward Beecher as a young man. That represents the hierarchy of E22 human-made object. The part of its scope note is as shown in the middle of this slide. So the problem is it appropriate to use this for illustrating the hierarchy? And to go straight to the bottom line, this is not an appropriate property. P198 can relate a sheet of paper in the envelope to that envelope, but that doesn't intend to represent a group of sheets. That group of sheets and each part material is represented in other property. We can find the fatal difference in the scope note also. That says, and will go out of existence at the same time as the destruction of the container or surface. That means if the package of postcards is lost, the groups of postcards will disappear. But even if the package of postcards is lost, the importance of the group of postcards won't be lost. That is apparent in the concept of archival group. So we have to find another property. There is previous research which tackled this problem. Bantry et al. 2011, mapping encoded archival description to CIDOC CRM. Encoded archival description is a well-known and widely used standard for encoding descriptive information regarding archival records. This figure is from that paper. There are three types of entities related to the physical object. In other words, E22 human-made object, archival description of that object is connected with P70 documents. P73 information object is carried by that object, and the information object referred to linguistic object. Those connected element is related with to that human-made object. I sometimes say human-made object and man-made object that because that is renamed, and in this paper that is called the former name the man-made object. And each of them have hierarchy connected with the composed of property. There are two properties named composed of. One is for symbolic object and one is for physical things. Anyway, four same-shaped composed of hierarchies are connected. This is the core of the model proposed by Pantari et al. And hereinafter I refer this as a boundary model. The third hierarchy, hierarchy of information object, corresponds to the schema is part of hierarchy. From now, I will explain about detail of that. To model the example of survey reports of clocks, there appears a nesting structure. We are documenting that survey card, and each survey card documents each object like clocks. So two boundary lattices appears. We here focus on the first lattice survey card as a documented object. As I said in the previous slide, the third hierarchy of information object, corresponds to the schema is part of hierarchy. There is a side evidence of this correspondence. Schema.org has a class called Creative Work, and there is a class closely related with it in LRMOO. In the document of LRMOO, E89 propositional object is the superclass of F1 work. This is a top-level class of LRMOO and very close to schema creative work. And the LRMOO is formally known as Fabaru, and this is developed and together with CIDOC CRM. In the document named IFRA Library Reference Model, a conceptual model for bibliographic information, there is a description of relationship between LRM, Fabaru, and CIDOC CRM. Recently, libraries, especially university libraries, organize not only books but also research data, digital archives, and so on. Therefore, the concept of work is generalized and the relationship between works and related classes are defined in detail. And in that model, E89 propositional object is the superclass of F1 work. LRM distinguishes two types of concept, work and its expression. For example, the work known as Eine kleine Nachtmusik is realized through the musical notation found in the editions of Eine kleine Nachtmusik from 1989, such kind of specific edition. On the other hand, such a relationship is described with work example property in the schema vocabulary. The domain and range of that property is both schema creative work. Thus, schema creative work is regarded as union of F1 work and F2 expression. The schema archival component is subclass of creative work, and in boundary model, we want to map that with E73 information object. We cannot entail subclass of relationship between them, but at least that relationship doesn't contradict with other relationship here and seems reasonable. E73 information object is subclass of E89 propositional object, and F2 expression is subclass of E73 information object. So it is reasonable to think archive component as a subclass of information object. In conclusion of this hierarchy problem, we can connect schema.org world and CIDOC CRM world seamlessly as regarding the schema archive component as a subclass of CRM E73 information object. This enables us to denote the archival aspect of information object and at the same time describe the relationship with its document and its carrier physical object like boxes and files or so. Next is documentation activities and its about the documentation activities and its result. This is important in representing knowledge accumulation process because different activities denote different knowledge. There are many ways to represent old knowledge. Roughly, there are two ways, in the knowledge graph directly or not. We adopt hybrid strategy of those two. To provide downloadable files is common practice in research data management and sharing. So download URL is connected in schema.org vocabulary. I won't speak detail about this because I didn't map this with CIDOC CRM. Google uses schema.org vocabulary for sharing research data in Google Dataset Search, and only the description in schema.org vocabulary is enough practically in that part. I'll talk about the relationship between archival component and activity related to it. That is described in the knowledge graph directory. So let's find the CIDOC CRM equivalent for them also. This is the core component of what we want to map. As a result of allocation action activity, archive component is created, and that is updated as an object of update action. Allocator action is defined in the scope note that the act of organizing task object events by associating resource to it. And this is a kind of organized action and different from create action. But the corresponding activity class is the creation because CIDOC CRM don't distinguish those kind of actions. And result of that action is E28 conceptual object, which is superclass of archive component, as we regard E73 information object is superclass of that. How about update action? Intuitively, that can be corresponding to E81 transformation, which didn't contradict before. Yes, that is before. Now it is inappropriate class for this usage. From version 7.1.1, which is the second latest published version, the scope of E81 transformation is reduced. Digitization of survey cards are not transformation activity, but creation activity according to this instruction. This is written in the third paragraph. If these properties were applied in the source to instance of conceptual object or its subclasses used in the migration target creation instead of transformation. So this is depend on the types of update activity. If that along with physical change, we have to apply multiple instantiation. In other words, that activity is both creation and transformation or production. So. Thus, both allocate action and update action is written as a creation activity, basically. Properties for connecting that activity with the result object is P94 has created. This is corresponding with a schema result property. There is a similar model in another ontology. The figure here is from description of prob ontology. That is abbreviation of provenance. This ontology model the provenance information as the relationship among three types of things: entity, activity, and agent. The property was generated by here is corresponding to the inverse of CIDOC theorem AP94 has created and schema result property. Similarly, the property used is same as used specific object, schema object. By mapping these properties, we can regard our description in schema and CIDOC CRM vocabularies as description of provenance of information. In CIDOC CRM, there is a technique to express provenance of each tuple. I'll explain the detail of that later, but we propose a property assigned attribute to in period as a shortcut property of consists of attribute assignment and such that assigned attribute to of that. The rationale of this is that in most of the cases, to write the provenance of the information in detail is too redundant, and it is enough to relate each activity and documented knowledge. Only in some cases, we have to write the provenance in detail. In this example, the production time of human-made object falls within Edo period, the original card says. And the fictitious relationship that production time falls within different period, which cause the contradiction, can be described using attributes assignment activity. This explanation is from chapter Authorship of Knowledge-Based Contents. Attributes assignment can describe the provenance of the knowledge in a similar way to the reification technique in RDF. Subject, object, and their relationship is denoted with their corresponding properties. As I mentioned earlier, this is too redundant if the production time is only described in one information source. So shortcut path from the activity to production time is needed. Anyway, that means the creation activity consists of multiple attribute assignment activity. That can be also the part of the multiple instantiation of creation and production, because the creation of the card accompanies the physical result. We can extend a boundary model with this activity hierarchy. HIO hierarchy, which is carried information of a human-made object, is the object of documentation activity, and the result is the leftmost hierarchy in the original boundary model. We can connect to HPO hierarchy, that is the second leftist hierarchy, regarding the activity is an instance of E12 production also. Thus, we can connect the activity hierarchy with three hierarchies of boundary model. Moreover, this kind of activities can be documented also. This added a new hierarchy in the left. This hierarchy is connected with the property P106 composed of. We call it a hierarchy of activity documentation, both the hierarchy of human-made object documentation, and that is HDEA, and hierarchy of activity documentation, same types of hierarchy, that is a hierarchy of document, and which means we can infinitely repeatedly create those hierarchies, but practically update action creates its self-description also. So from each data like production time of clocks, we can search each activities with P101 assigned and P100 assigned attribute to, or shortcut of them, and we are proposed. And that is the extension of boundary model. In this slide, we will expand the model for archival components to other types of components. We don't model implicit cluster because it is implicit. We can correct the object made in same error by querying that data with Sparkle, query languages for knowledge graph. All we have to do is make the data as consistent as possible by using controlled vocabulary such as Getty vocabulary also. On the other hand, explicit clustering such as materials related to small online exhibition or such can be represented in the same way as the expanded boundary model. Viewed from the opposite side, it is not obvious that the target information object is archive component. So we have to describe explicitly using appropriate class like schema archive component. This is a conclusion slide. We extend the boundary model for documenting the knowledge accumulation process consistently, added the document creation activity hierarchy and activity documentation hierarchy, mapped schema.org vocabulary and CIDOC CRM vocabulary for practical key usage, and proposed a shortcut property assigned attribute to in period. That avoids the redundancy of the attribution assignment description. And connected to the research data management process to knowledge graph by using schema.org properties. By regarding archive components as a specific type of information object, archive and non-archive components are represented in the same way and easy to query. And we can connect CIDOC CRM description with archives and long-term preservation community vocabularies like premise. That's all. Thank you.
Just a second. I will ask first if the audience has any reflections, any questions on this fantastic presentation and continuation of a project presented 2 years ago. Anybody? Okay, can I have the microphone to Linda in this end? It is always pleasure to see things going on and being revisited in the conferences one after another.
Yeah, thank you very much for your very impressive presentation of your very sophisticated modeling with CIDOC CRM. And we are currently challenged by maybe a same task, and that's you, because we are modeling the textual sources right now in our project, and we were thinking of how to link it to the human-made objects. And in particular, often we have the case that we can't really only relate to the documents, but also to depictions or images with a specific page within the documents. So how would you suggest to deal with that? That would be awesome to know. Thank you.
Thank you for a question. I'm using that composed of property for documenting such kind of a part of the document. We also have the photograph or sketch or such kind of part of the document as a document part of survey cards, and we have to represent that with that composed of property. Thank you.
Thank you. Are there any other questions from the audience? If not, there is still probably time for my very practical question, because in the abstract, you are talking about users, how users can browse the information. So do you offer this opportunity only for researchers, or do you pass the data on to the larger public, for example, through this Japan search? Can you say a few words about that?
Yeah, thank you for your question. Using Sparkle or such kind of a little bit high level technique is supposed to be used by researchers, but of course, we will publish the data to Japan Search, and that will be used by a larger public. And we also are planning to make a specific interface to each specific purpose. Like if we have to preserve the materials in local community, we have to make an interface for local communities also. So through such kind of specific interface, we will provide the functionality to larger public. Thank you.
Great, thank you. Are there more questions? Let me just check if I have anything here from the workshop. No question from the online audience. So I think we are then saying thank you once more, arigato, to you and your colleagues. It was nice having you here with us.